Everyone thinks this problem is childish. That's exactly why it's dangerous. You're standing outside, rain pouring down, and your brain instantly snaps to a conclusion: run, you'll get less wet. Or sometimes the opposite: walk, running makes it worse. Nobody pauses to ask why they're so confident. And that's the moment Feynman loved. The moment when the mind stops questioning and starts assuming. You see, the universe doesn't care that the question sounds silly. Rain doesn't become simpler just because you're late for work. Physics doesn't lower its standards because the problem involves shoes and puddles instead of rockets and atoms. If you're willing to ask the question seriously, the universe answers seriously. And the answer is never what intuition promises. What makes this question fascinating isn't rain, it's the arrogance hidden inside the question. We assume we already know how the world works because we've experienced rain our entire lives. We've been wet before. Surely that counts as expertise. But experience is a terrible teacher if you don't analyze it. Experience tells you what happens, not why it happens. Feynman was obsessed with that difference. At first glance, the logic seems airtight. If you run, you spend less time in the rain, so less water should hit you from above. End of story. But that's where the trap snaps shut. Because rain doesn't politely fall straight down into your personal coordinate system. You are moving through it. And the moment you move, you've changed the problem without realizing it. Now rain is no longer just falling, it's colliding. You're sweeping through a volume of water that didn't need to hit you before. Your chest, your legs, your face, they're now intercepting droplets that would have missed you entirely if you had stayed still. Time decreases, yes, but exposure changes. The question mutates while you're answering it. Feynman would stop right there and smile because this is the exact moment intuition collapses. The brain wants a single lever, run or walk, but nature doesn't work with single levers. Nature stacks variables on top of each other and waits for you to notice. Rain from above depends on time. Rain from the front depends on speed. And the moment you realize there are two different kinds of wetness, the simplicity evaporates. This is why Feynman treated questions like this with respect. Not because they're practical, but because they reveal how sloppy human thinking can be. We love answers more than we love understanding. We'd rather be confidently wrong than curiously uncertain. The rain paradox exposes that instinct brutally. And here's the quiet punchline. The problem isn't that people don't know enough physics. It's that they don't know when they're guessing. The universe doesn't punish ignorance. It punishes certainty without thought. Rain just happens to be polite enough to demonstrate it without killing anyone. That's why this tiny, ridiculous question matters. Because if your intuition can fail you while walking down the street, imagine how often it fails you when thinking about time, space, motion, or reality itself. The rain isn't teaching you how to stay dry. It's teaching you how easily the mind gets soaked in its own assumptions. Once you accept that the question isn't trivial, the next mistake people make is trying to rescue it with a single clever idea. They say, it's about time. Less time in the rain means less water. And that sounds scientific enough to end the discussion. Feynman would shake his head at that because it's not wrong. It's incomplete. And incomplete answers are often more dangerous than wrong ones, because they feel finished. The trouble starts when we lump all the rain into one mental bucket. Rain is rain, water is water, what's the difference? But physics survives by refusing to do that. The moment you stand still in the rain, water is falling vertically onto the top of you. That's one process. The moment you start moving, a second process appears. You begin to collide with raindrops that were never aiming for you in the first place. These are not the same thing. And nature keeps separate books for them, even if your intuition doesn't. Think of it this way. Imagine freezing the world for a moment. The raindrops are suspended in the air like tiny beads on invisible strings. Now you choose a path through them. If you walk slowly, you pass through fewer beads per second, but you do it for a longer time. If you run, you slice through a larger number of beads per second, but you stop sooner. Time and speed pull in opposite directions, and neither one wins outright. The universe doesn't hand out discounts just because you're in a hurry. This is where the phrase from above and from the front suddenly matters. Rain from above cares only about how long you're exposed. It doesn't care if you're sprinting like an Olympic athlete or strolling like you've got nowhere to be. Gravity doesn't clock your speed, it clocks your patience. But rain from the front is a different beast. It cares intensely about how fast you're moving, because speed determines how many droplets you plow into. What people miss is that these two effects don't cancel neatly. They depend on different aspects of your motion, different parts of your body. Your head and shoulders mostly deal with rain from above. Your chest, legs, and face deal with rain from the front. The geometry matters. The shape matters. Even how you lean forward matters. At this point, anyone hoping for a tidy yes or no answer is already in trouble. Feynman loved problems like this because they expose how badly we want nature to be simple on demand. We want one cause, one effect, one rule we can memorize and reuse forever. But the rain refuses. It insists that you define exactly what you mean by wet. Are you counting drops? Measuring mass? Considering surface area? You don't get an answer until you decide what you're actually asking. And that's the real lesson, hiding in the drizzle. Physics doesn't reward clever slogans, it rewards careful bookkeeping. Once you realize there are two different ways to get wet, you stop arguing about running versus walking, and start appreciating something much more important. The world is precise, even when our questions are sloppy. The rain isn't confusing. We are. Now something subtle happens, and this is the part people almost never notice. When you start moving, you don't just change how fast you go, you change what the rain is to you. That sounds poetic, but it's brutally literal. Motion rewrites the problem. The rain hasn't changed its mind, the clouds haven't adjusted their strategy, yet the pattern of impacts on your body transforms the instant you take a step. Physics calls this a change of reference frame, but you can feel it without knowing the term. Stand still and the rain is polite. It falls straight down, taps the top of your head, and ignores your chest. Start walking and suddenly it has an attitude. Tilt your head forward slightly and you'll feel it pepper your face. Speed up and now the drops seem to arrive at an angle, as if the rain has decided to chase you. Of course it hasn't. You're the one doing the chasing. But the universe reports events relative to you, not to your excuses. Feynman loved this kind of thing because it shows how easily we confuse appearance with cause. People say, the rain is slanted today. No, it isn't. You're moving. The slant exists only in your description of the world. But descriptions matter because they determine what you count, what you measure, and what conclusions you draw. Change the frame and quantities that felt obvious suddenly need rethinking. Here's the quiet shock: the faster you run, the denser the rain appears in front of you. Not because there are more drops in the sky, but because you're intersecting more of them per second. It's the same reason bugs splatter on a windshield instead of gently landing. From the bug's perspective, nothing special happened. From the car's perspective, it drove into a storm of insects that seemed to come out of nowhere. Motion manufactures collisions. Onk. You see this? The idea of escaping rain by speed starts to look suspicious. You're not outrunning the water. You're rearranging how it meets you. Time shrinks, impact rate grows. Which one dominates depends on geometry, speed, and even posture. The problem refuses to be reduced to a slogan because reality isn't optimized for slogans. Feynman would point out something even more unsettling. In one frame, running helps. In another, it hurts. And neither frame is privileged by nature. The laws are the same, only the bookkeeping changes. That's a hard pill for intuition to swallow, because intuition wants a single observer-independent answer. Physics says, tell me how you're moving, and I'll tell you what happens. No motion, no story. This is why the rain paradox feels larger than it is. It quietly introduces you to the same idea that governs time dilation and length contraction. Motion doesn't just change numbers, it changes meaning. Quantities you thought were absolute turn out to be conditional, and if something as harmless as rain can teach you that, imagine what motion is doing to your ideas about time, space, and reality while you're not paying attention. The rain isn't falling differently. You are moving differently. And in physics, that makes all the difference. At some point in thinking about this, a strange thing happens. You realize the problem refuses to end. Every time you think you've nailed it, another detail sneaks in and ruins the celebration. And that's the moment people usually get impatient and ask, all right, but which is it, running or walking? Feynman's reaction to that question is the real story here, because it shows what it means to actually think like a scientist. The honest answer is uncomfortable. It depends, not in a lazy way, but in a precise, unforgiving way. It depends on your shape, your speed, the density of the rain, whether there's wind, how upright you are, how long your path is, even how you move your arms. Once you see that list growing, you understand why Feynman stopped running, not physically, but intellectually. He refused to chase a fake certainty. Most people treat it depends as a failure. Feynman treated it as a victory. It meant you had finally stopped lying to yourself. The universe doesn't owe you a simple answer just because you want one. If you don't specify the conditions, nature will happily produce multiple outcomes and dare you to complain. There's a deeper reason this matters. People think physics is about answers. Feynman knew it's about questions. A bad question can't produce a good answer, no matter how smart you are. Will I get wetter if I run? Sounds clear, but it hides a mess of undefined terms. Wetter how? Over what distance? In what kind of rain? Compared to what posture? The moment you start tightening those definitions, the illusion of a universal answer evaporates. This is why Feynman would often stop calculations halfway through and laugh. Not because he was confused, but because he discovered the question was broken. Continuing would only produce a number that looked impressive and meant nothing. That kind of honesty is rare because it doesn't feel productive. It doesn't give you a punchline to repeat at parties. But stopping is sometimes the most scientific move you can make. It's a refusal to pretend that the world is simpler than it is. In the rain parade, ox. Stopping means recognizing that your desire for a neat conclusion is part of the problem. You're not trying to understand rain anymore. You're trying to win an argument. And here's the irony. Once you accept that there's no single correct answer, you actually understand the situation better. You can predict what will happen in specific cases. You can design experiments. You can say, in heavy vertical rain, running probably helps, and in light rain with strong wind, it might make things worse. That's real knowledge. It's conditional, precise, and humble. So when people say Feynman stopped running, they miss the point. He stopped running toward false certainty. He slowed down enough to notice that the universe doesn't give out answers without demanding clarity in return. And that, more than staying dry, is what physics teaches you. How to know when to stop, think, and admit that the problem you're chasing isn't as simple as your intuition wants it to be. Once you've gone far enough with this problem, something slightly embarrassing becomes obvious. The rain didn't trick you. Physics didn't ambush you. Your own intuition did. And that's the part Feynman cared about most, because intuition has a bad habit of pretending it's smarter than it is. Intuition feels authoritative. It doesn't argue, it declares. It says, obviously running helps, or obviously it doesn't. With the confidence of someone who has never checked. That confidence comes from evolution, not truth. Your brain is optimized to keep you alive, not to solve problems correctly. If a shortcut worked well enough in the past, intuition keeps using it even when the situation changes. The rain paradox exposes this brutally. You feel like less time must mean less water, because in most daily situations, time is the dominant factor. Stay longer, get more of whatever is happening. That rule works until it doesn't. The moment motion introduces a second mechanism, collisions from the front, the shortcut fails. But intuition doesn't back down quietly. It doubles down. It ignores the second effect and insists the first one is all that matters. Feynman warned about this kind of thinking constantly. He called it fooling yourself, and he emphasized that you are the easiest person to fool, not because you're stupid, but because your brain is persuasive. It gives you a story that feels complete long before it actually is. The rain feels simple, so the explanation must be simple. That's the lie. What makes this dangerous isn't rain, it's transfer. The same intuition that fails here is the one people trust when thinking about probability, risk, time, and cause. We think faster means better, more effort means more result, longer exposure means greater effect. These are not laws of nature, they're habits of thought. Nature doesn't care about your habits. The uncomfortable realization is that intuition is context-dependent. It works wonderfully in some regimes and collapses in others. Feynman loved showing this because it forces humility. You don't get to know in advance when intuition will betray you. The only defense is skepticism, especially of ideas that feel obvious. This is why science looks slow and cautious from the outside. It insists on definitions, measurements, and assumptions written down where everyone can see them. It doesn't trust the feeling of understanding. Feynman argued, that feeling is irrelevant. You either understand something well enough to explain the conditions under which it works, or you don't understand it at all. In the rain paradox, intuition wants closure, science wants clarity. Intuition asks, so what should I do? Science asks, under what circumstances does each choice lead to what outcome? One is about comfort, the other is about truth. And once you see that difference, you can't unsee it. You start noticing how often your mind reaches for the easy answer just to stop thinking. The rain becomes a quiet warning sign. If intuition can mislead you here, where the stakes are wet clothes, imagine how confidently it misleads you when the stakes are higher and the variables are hidden. Feynman didn't distrust intuition because it was useless. He distrusted it because it was powerful. Power without discipline is dangerous, and the rain, of all things, is polite enough to demonstrate that lesson without hurting anyone, unless you insist on running blindly toward answers that only feel right. By the time you reach the end of this little journey, the rain has almost disappeared from the story. It's still falling, of course, but it's no longer the point. What's left is a shift in how you look at ordinary things. The rain paradox starts as a practical question and quietly turns into a lesson about how the world hides its complexity in plain sight. Once you accept that something as mundane as walking in the rain can't be answered with a slogan, you're forced to reconsider how many other obvious ideas are built on the same shaky foundation. We walk through life surrounded by phenomena we think we understand because we've seen them before. But familiarity is not comprehension. It's just repetition without curiosity. Feynman believed that the universe is under no obligation to match our expectations. The job of science isn't to make reality feel comfortable, it's to describe it honestly. The rain paradox does this beautifully because it punishes overconfidence gently. No equations are required to feel the discomfort. You just have to notice how fast certainty dissolves when you ask the question properly. And that's the real transformation. You stop looking for final answers and start looking for better questions. Instead of asking, what's the right choice? You ask, what assumptions am I making? That change sounds small, but it rewires how you think about everything, from motion to time to cause and effect. The paradox also teaches patience. The desire to rush toward a conclusion is strong, especially when the problem feels small. But small problems are often where sloppy thinking hides most comfortably. Feynman loved digging there, not because it was efficient, but because it was honest. Big theories collapse when small assumptions go unexamined. There's also a kind of intellectual humility that grows out of this. You realize that not knowing isn't a failure, pretending to know is. The rain doesn't demand that you solve it perfectly, it only demands that you respect the complexity it represents. Once you do that, you're no longer arguing with nature, you're listening to it. And here's a quiet payoff. The next time you face a problem that feels overwhelming, about time, reality, or even your own life, you might remember this moment. You might pause instead of sprinting toward the first answer that offers comfort. You might ask what's missing, what's undefined, what's being ignored. That pause is where understanding lies. Feynman stopped running not because the rain won, but because the question evolved. He realized that the goal wasn't to stay dry, it was to stay honest. The universe rewards that kind of honesty with insight, even if it costs you a little discomfort. And in the end, being slightly wet is a small price to pay for seeing the world a little more clearly.